In this screen recording, I'm going to introduce you to the concept of hexadecimal. So, you should already be familiar with the concept of decimal and the concept of binary. So, in decimal, we have 10 characters which we use. So, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Hence decimal for 10 different characters. Des comes from the Latin meaning 10. Alright, and then you also know binary. Now binary is called binary, BI meaning 2 from Latin, simply because there is only 2 digits. And so we are going to introduce you to a new concept, hexadecimal. Now hex, as you may know, refers to 6, but in this case we are referring not to 6 but a base of 16. So what does that mean? We have these characters in hexadecimal. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So just like with decimal, these are all the same characters, but then we use letters to represent the next numbers. So the number 10 is represented by an A, the number 11 is represented by B, number 12 C, 13 D, 14 E, and 15 F. So we have 16 separate characters. Alright, now I may just get rid of what I just wrote. Where is my eraser? Okay, and just eliminate this stuff, because what I want to do now is focus exclusively on binary and hexadecimal. Okay, so as you know, in binary we normally start from the right. So just imagine we have a table like so. And I'll show you just the start of binary, maybe the first 5 or 6. So with binary, in the first column we start with 1, then the next column we double it, which gets us to 2, we double that to 4, we double that to get to 8, 16, 32, and so on. So therefore, if we get the number 0, 1, 0, 1, 0, 1, we simply write it in the column here to work out what it is in decimal. So we can start with 1, 0, 1, 0, 1, and then we simply add up the columns. So it is the same as 16 from over here. We ignore the 0, plus 4 from here, plus 1, which equals to 21. So 1, 0, 1, 0, 1 equals 21. So let's apply this to hexadecimal. So we can again draw up our table. We might keep it a bit smaller. 1, 2, 3. So imagine we start with the 1s, then in the next column we go to 16. So we multiply by 16 each time. So 1 times 16 gives you 16. 16 times 16 gives you 256. And then 256 times 16, we might use our calculator. Gets you 4096. Okay, and so let's imagine we are given 2 characters. Imagine we receive, say, a 3, and the other character receive is an E. So we know that E is the equivalent to 14. Remember, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and A represents 10, B represents 11, C represents 12, D represents 13, E represents 14. So E is the equivalent to 14 in hexadecimal. So therefore, we put a 14 in our first column because E is the far right. Now we also know that 3 here simply represents 3. So we put a 3 here. However, we have to multiply this 3 by this number. So we multiply 3 by 16, and of course we multiply 14 by 1. And so therefore we get 16 times 3 is 32 plus 16, 48. And then we add this number to this number. So 14 times 1 is 14. And so therefore, if someone gives you the number 3e as a hexadecimal number, by using this table, and of course understanding that e represents the number 14, you can conclude that this number is actually 52. Maybe one or two more examples for you. Let's imagine we get the number 1f. How would we convert that? Let's clear our table a little because it's getting a little messy. Once again, you take the right column. In this case, our right column is f. And as we know, f is going to be 15. Remember, 10, 11, 12, 13, 14, 15. And of course, 15 times 1, because this column is 1. The other number is 1, so 1 times 16. And then we simply add 16 to 15. And then we can work out that 1f in hexadecimal is the equivalent to 31. Okay, now the other thing you need to know is how to convert from a decimal number into hexadecimal. Now, once again, we should draw up this little table. Or first we should write out all our digits, so we know we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But actually we don't have a 10 in hexadecimal. We represent 10, as you may recall from earlier, with a letter A, and we represent 11 with B, and 12 with C, 13 with D, 14 with E, and 15 with F. And you'll recall our little table from earlier. Where we have 1, 16, and 256. Now, so here I want to explain how you can convert decimal numbers into hexadecimal, the opposite. So imagine we've got these three numbers, we want to convert them into hexadecimal. A good way to start is to actually write out your 16 times tables. So let's say we've got 16, or let's say we've got 1, 2, 3, 4. We'll write a line across here, make a little table. 5, 6, 7, 8, 9, 10, 11, 12. And then on the right side we're going to write what that number is multiplied by 16. So 16 times 1 is 16. 16 times 2 is 32. We can do a bit of a shortcut. Double 32 to get 16 times 4. Double 64 to get 128. And of course 16 times 10 is easy to work out. That's 160. we can add 16 to that to get 16 times 11, which is 176, and add 16 to that, which is 192. Okay, so then 160 minus 16 gives us 144. 128 minus 16 gives us 112. 112 minus 16 gives us 96. 96 minus 16 gives us 80. And 32 plus 16 gives us 48. I think more or less that's right. I'm just not sure about the last couple, so I'll just double check. Okay, it looks like our table is all more or less correct. Now, let's work out 99. So, when you get the number 99, the first thing you want to do is work out how many 16s are in 99. And you can see there are 6. So, here we can do something like this. 6 times 16 plus, and if you take 96 away from 99, you are left with only 3. So 1 times 3. So if you multiply 16 by 6 and add 1 times 3, you'll get 99. So then we've got to work out how we can write this. So we take the 3 from here, and this becomes our right column, which is 3. And then we take the 6 from here, which becomes our left column. So 99 in hexadecimal can be written as 63. The 3 here, the 6 here. Okay, let's clear that one and do some more examples. How about we work out 18? Okay, so let's work out how many 16s there are in 18. There's obviously only 1, so we can do 1 times 16, and then there plus 2 times 1. Therefore we take the 1 from here, put that in our right column, and we take the 2 from here and put that in our left column. So 18 in hexadecimal is written as 1, 2. Okay, let's do the final one. Once again, grab my eraser. 209, a little bit more complex. Now we can see that 192 times 12, well, that 16 times 12 equals 192. So we know, therefore we can put 12 times 16 and actually we can even probably add 16 to 192, which will give us 208. So we can do 13. And so actually it's going to be 13 times 16, which will leave us with 208, and that just leaves 1. So then we've got 1 times 1. So if we've got a number 13, it's a bit different. We're going to have to write a letter. So you got 9, 10, 11, 12, 13. So remember these letters represent 10, 11, 12, 13, 14, and 15. So in this case, we're actually going to have to write the number 13 as a D in the left column, representing this, and then 1 in the right column. So 209 can be represented as D1. And that concludes my introduction to hexadecimal. I hope it has helped. If it hasn't, I will do a little introductory tutorial to 5.24, 5.25, and 5.26 to help you.